Here we go. Story of the century. Starting audio in 3, 2, 1, click. And welcome everybody to this week's exciting episode.
And I think it's gonna be a long, long time till touchdown brings me round again to find I'm not the man they think I am at home. Oh no, no, no. I'm a rocket man. Rocket man. Burning out his fuse up here alone. I'm not going to do the rest. That was long enough.
It was. Very good William Shatner impression.
Oh, it's terrible. I really wish I could do more impressions.
It was more like William Shatner than it was like Elton John, let's put it that way.
Yeah. That's good. I don't want to be like Elton John.
No. For more reasons than one.
Yeah, especially the early days. Oh.
You've got more hair, so...
Yeah, true.
Than the early days.
That's never going, my friend. I'm going to have a full head of hair to the day I die.
I would hope so.
Yeah. Well, unless I get alopecia. Then...
I've got the number of a guy that can help you out even if it does go. So don't worry about it.
Well, what's going on?
This week, I've possibly got what could be the story of the century.
Breaking news.
Well, it's already broken.
Oh. I thought you had an inside scoop.
I don't have an inside scoop. I'm going to try and clear up some discrepancies, shall we say.
Oh, okay.
Because, at the time this goes out, it'll be several weeks ago. But for us recording this at the moment, in the last sort of 10 days, story has dropped that we are waiting to confirm. But there's been some clickbaity videos on YouTube, man, saying that we have found aliens.
Confirmed or waiting for the confirmation?
We are waiting for the confirmation.
Of aliens?
Yes.
So I'm guessing you mean aliens are here?
No.
Oh.
No. Cast aside all these thoughts of UFOs, little green men landing on the planet and saying, we've come to see your leader. Right? That's not what we're talking about. What we're talking about is a radio signal that has been supposedly detected from outer space, from outside of this solar system, completely away from here on Earth. Do you want to hear it?
Yeah, I do, actually.
I've got it.
I'm intrigued.
Loaded up on my phone.
You've tickled my teats.
I'll try and get a higher quality version of this for the release on the podcast, but just for us to hear it right now, this is it. Isn't that good? Don't know why. Oh, my speaker's turned off. Okay.
Take two.
Take two. This, editor. Right. This is it. Good, isn't it?
Oots.
It's got rhythm.
Yeah, it has. I like the first bit.
Yeah, that's quite cool. But yeah, I don't know if that is actually what you would actually hear if you were one of the aliens that were picking up on that signal. You might need to decode it or something. But that is an audio waveform of the signal that we've heard.
That's interesting. I have a question already.
Okay, go on then. Let's get your question out of the way.
You know, like they say the speed of light traveling through space, how fast is the speed of radio waves?
Pretty much the same.
Oh, okay.
Yeah.
Oh, that's easy to remember.
Because light is all part of the radio spectrum, isn't it? Everything from gamma waves up to X-rays, infrared to ultraviolet. It's all radio frequencies.
Oh, okay.
Basically, so it all kind of travels at near enough the same sort of speed.
Okay.
Different to sound waves. Radio waves are different to sound waves. That's the difference. So the speed of sound is a lot less than the speed of light, but radio waves travel more or less closer to the speed of light.
That is interesting.
But before we actually get to this breaking news, if you like, the story of the century, I'm going to explain. It's been ages since we've done a sciencey one, like a proper sciencey one. So I'm going to explain the steps that we've taken to actually get to here, get to this
To
point.
get to this pinnacle point.
Yes. And some of the anomalies that we've discovered along the way as well. Because this isn't the first time that scientists have thought that they found alien life or traces of alien life outside of our solar system. And I guess to start it all off, we need to talk about exoplanets in general, planets outside of the solar system that are orbiting other stars. Did you know they were called exoplanets?
Yes, Omicron Persei 8.
That's where Lure comes from.
Yeah, that's one.
Yeah.
No, I do know about the planets that aren't as popular. They're not in the solar system, so they've got weird names and things, aren't
They're
they?
generally named after the star that they're
Yeah.
around. Now, do you know how I know you know because I told you
Yes.
yesterday, there are 3 main ways that we can detect planets.
Can I remember?
Can you remember them?
Okay.
Now, there's 6 points on the line. There's 1 point for the first answer, 2 for the second answer, and 3 for the third answer. So that's 6 in total.
So the first one is like just an observation through telescopes.
Yeah, direct observation. It's probably the most difficult one to do.
Yeah.
It doesn't happen very often, but yeah, direct observation. Ding, 1 point.
I know the other one was to do with gravity.
Yes.
So I remember you saying about the way the stars and the planet move.
Yeah, so I think the analogy that I gave you yesterday was imagine the stars and the planets are like a swing ball. You remember the game Swing Ball,
yeah.
where you put the pole in the garden and it's got a string attached to it with a tennis ball. You whack the tennis ball and it goes around and around the pole. Now, if you did that and you whacked that tennis ball really hard and it just went round and round and round, it would be in orbit of that pole. And imagine there's a big bright light on the top of the pole. As that tennis ball's going round, what would happen with the light was it would wobble around, the tennis ball would kind of be dragging the pole off center, which is more or less, not exactly, but more or less what happens with stars and planets. A planet isn't just orbitally bound to or gravitationally bound to the star. In the case of like really big planets like Jupiter, because they're so massive, that planet also, the gravity of it affects the star, and it makes the star wobble.
Yeah.
So you've got gravitational wobble. So when scientists look into the night sky with their telescopes and they can measure the exact distance between 2 or 3 stars, and if one of them seems to be sort of moving around a little bit, you can bet your bottom dollar that there's a planet going round it.
That makes sense.
So that's ding, ding, 2 more points.
Third one, I think I've forgotten. Is it to do with the position of the stars, like horoscopes and things?
No, definitely nothing to do with horoscopes.
Is it to do with the brightness of the star?
It is. Can you remember? Oh, that might jog your memory. No.
Is it? It's the opposite, isn't it? So if it's dim, there's
Yeah.
it's a sign of planets.
Yeah. Okay. So let me pull up the analogy that I said to you yesterday. Now,
Yeah.
here on Earth, we are on Earth. The sun is in the sky.
Ah, yeah.
The moon is in the sky.
Yeah.
And sometimes the moon passes in front of the sun.
Yeah.
And what happens then?
Goes dark.
Yes, it goes dark. And this, you can see that out in the stars with planets as well. If you're looking at a star really, really far away, and you know how bright it is, this is what's called its magnitude, how bright it normally is. Yeah. And if you see that star light dim just an itty bitty little bit. An itty bitty bit. That's all it is, just really, really tiny amount. It's probably because there's a planet going in front of it. Yeah? Now, normally, even like a planet the size of Jupiter going in front of a star that's like thousands of light years away, like really, really long, mind-bogglingly large distance away, right? The starlight, the amount that it dims, is only up to about 1% of its total brightness.
And they can detect that.
Yeah, that's how small amount of dimming it is. Really, really small.
That's impressive.
Now that we got that out of the way, let's tell you about the first few anomalies that we found when we've been looking for exoplanets like that.
Why are they called exoplanets?
I'm not sure what exoplanet is short for, but it's
Kiss and a hug planet?
Kiss and a hug planet, yeah. Anything that's outside of our solar system is known as an exoplanet, basically.
Okay. Right. Oh, so it's is it more exo as in like,
external? If you like.
Yeah.
External to
I
our
was
solar
picturing
system.
just an X and an O.
No, exo, EXO planet. So yeah, there's now we've got some anomalous stories, shall I say? Some of these I know I can back up because I've looked them up on scientific papers and stuff. One of the first one that I want to bring to your attention, I can't say that I've actually looked into this far enough to actually look through scientific papers and that sort of thing, but I have heard from several sources that in the case of one such star, they were trying to identify exoplanets, and they thought they'd found a whole bunch of them because they measured dips in the starlight. So I think it was 28 different dips. And through their measurements, they assumed that 27 of them were around about Earth-sized planets.
Okay.
And one was about double that size. Yeah, it decreased the light by double the amount. Now, normally, when we're looking for exoplanets, we would time it, basically. Once that dimming of the light has happened, we'd then start counting, days, weeks, months, however long it takes for that same planet to come around, to orbit the sun, or orbit its star, and then come around again. And then when you see the starlight dim by that same measurable amount, you can bet that if it was, say, 30 days, for example, since it happened last time, you can almost bet that in exactly 30 days, you'll see it happen again. Because that is the orbital period of the planet. Now, in the case of this star, I think it was called HD 138138, like I say, they saw 28 different dimmings of starlight. Like I say, and they assumed that it was all planets around about the same size of Earth. One of them was about double the size of Earth, and they waited for the orbital periods to start presenting themselves. And they waited, and they waited, and as far as I know, they're still waiting. Like, this never happened again. So what on earth could be so colossal that it dimmed the starlight enough to make us think it was a planet that has never completed its orbit? They've never come back round again.
I mean, my brain goes to the sci-fi kind of thing of like motherships and stuff like that.
It would be colossal. It would literally be the Death Star. It would be 30 times bigger than the Death Star.
Yeah. Well, that is a strange anomaly.
So that's an anomaly. Like I said, I've not dug through scientific papers to back that one up. That one is just a story that I've heard from other sciencey sort of reporters on YouTube and the likes. But there is another one using the same technique, the what we call the transit method, because when a star goes in front of the sun, when a planet goes between its star and us, it's an orbital transit. Yeah, it's transiting that star. Yeah, so they call it the transit method. Now there's another star. Now this one is quite famous. Well, if you're into your stars, And it's either known as Boyajian star or Tabby star. And this is because one of the scientists that was looking for exoplanets, Tabitha Boyajian, was looking at this particular star.
So she got to name both of them.
She got to name the star, but not necessarily because she found exoplanets. It's because she found something very, very weird was going on with this star. Right now, as I've told you, right, when a planet is transiting, the most we've ever known a planet in starlight to be blocked is 1%, as I already said. Yeah, that's the most amount we've ever measured a planet blocking in starlight. Now, as Tabitha or Tabby was monitoring Tabby's star, she noticed multiple times of the starlight being dimmed by up to and above 20%. And while she was doing this, she naturally, the next thing, her next port of call was to measure the amount of time that it happened again, thinking that it would be regular as clockwork, but it wasn't. It was very erratic. Sometimes it would dip by only 1% or less than that, sometimes 10%, sometimes 20%, sometimes 15%, and there was no rhyme or reason to it. There was no orbital metronome. It was irregular. It wasn't happening regular as
Strange
clockwork. Yeah, it was. There was no conceivable pattern to it. And
so, would that be proof of a planet?
Well, no. This is the thing. Scientists were baffled, absolutely baffled. There was talks of it being an asteroid belt that was causing it. Now, I know what you're thinking. You're immediately thinking of Star Wars, where Han Solo is being chased through an asteroid belt.
Yeah, done the Kessel Run in less than 12 parsecs. Yeah,
a parsec is a measure of distance, not time.
Not in Star Wars, baby.
Right, I'll explain to you what a parsec is.
No, I don't care. Han Solo is the way forward. He's the man. He knows.
Well, okay, he must have done it in less than, in less distance than anybody else. But anyway, this Kessel Run through an asteroid field is complete science fiction, because asteroid fields, yes, they are. It is like a belt. The asteroid belt that goes between Mars and Jupiter, for example, it is a belt full of asteroids, but not as densely populated as what Star Wars makes out. Where they're
more
dodging,
spread out.
Yeah, a lot more spread out. Where in Star Wars, they're ducking and diving and dodging and weaving all through these asteroids, and other planes or other TIE fighters or whatever are crashing into them left, right, and centre. No. Asteroids are so spread out, it would take, at the very least, hours to go from one asteroid to another.
Oh, right.
At best.
Yeah.
Normally probably days, weeks in between them.
Yeah.
They are very, very spread out.
Would they be moving quite quickly, or would they be almost stationary?
They're moving. Depends in relative to what.
Oh, depends which planet they're around or where the belt is.
I guess. But yeah, I mean that is the thing. So asteroids, because they're so spread out like that, it's very unlikely that a whole bunch of asteroids is going to be dense enough to block out that much starlight. I think it went up to something like 23% of the starlight was being blocked.
Yeah, that'd have to be a lot of asteroids.
A lot of asteroids, and it's irregular as well, which I guess kind of backs up asteroids, but again, not really, not anything measurable. That's because scientists like to measure and they like to be able to prove things, as we're going to go on and find out later in the show. So this is where someone actually came up with really radical explanation, but scientists were like, actually, this guy might have a point.
Oh, here we go.
Right. So have you ever heard of something called a Dyson sphere?
I know a Dyson, but...
A Dyson is a vacuum cleaner.
Yeah.
Well, Dyson, a different Dyson, also came up with the idea that, the computer game Halo?
Yes.
The halo is based on that giant ring in space.
Yeah.
Yeah. Now, if you imagine loads of those attached to each other and all orbiting a star very closely to it, like a giant grid around the star, like a cage.
Yeah.
All with solar panels on the inside of them facing that star. Imagine how much starlight that would gather. Unlimited power.
Unlimited power.
Exactly. Yeah. I don't know how the hell you'd build a Dyson sphere. It would have to be a very, very technologically advanced species to even contemplate.
This is not one of the
trying to-
explanations for this.
This was, honestly, the scientists actually came up and said possibly it's a Dyson sphere. Then they realised that they're kind of, clutching on the science fiction side of things, because we can't even contemplate how to build a Dyson sphere. It would have to be, like I say, a very, very advanced alien civilization that would have the technology to do it.
Yeah.
Although maybe they do.
Possibly.
This is the thing. So eventually, I think the scientists, or NASA or whatever, decided that they were just going to put it to one side and blame it on like interplanetary dust or extraplanetary dust that's just blocking this.
Well, like a cloud.
Like
a
a
dust
cloud of dust. That's the best, most reasonable explanation that they could come up for to explain this random dipping of starlight by such a vast amount that they because literally they just ran out of ideas. They were like, we don't know what is causing this. Now, our best guess is aliens, and scientists don't like blaming anything on aliens. They don't. They will clutch at straws with stupid theories like dust clouds, rather than actually say, "Oh, it could be aliens."
Yeah.
I
get it. So that anomaly has still yet to be explained. Yeah. Okay, that's pretty interesting.
Yeah, to convince 100% of people, we have not come up with a convincing enough answer that everybody's sold on it. Right? And that was Tabby's star.
Yeah.
Right? And now enters the search for extraterrestrial life. We might as well bridge that gap now.
Yep.
Right. So there is an institute called SETI, the Search for Extraterrestrial Intelligence. Yeah? It's a global institute. Everyone's in on it. Pretty much all the countries in the world have got scientists that are quite happy to work for SETI. They do real science research looking for real tangible evidence of another civilization somewhere in our galaxy. Yeah.
Oh, so no messing with these guys.
Messing.
That is their main mission.
That is their main mission, yeah. But they have been somewhat divided about how to approach this.
Oh no, there's divisions in every company, isn't there?
Yeah. Well, over in the USA, North America, and that, they wanted to do their survey of the sky, and what they wanted to do was look out for something really glaringly obvious. Aliens going, "We are here," waving a little flag, going, "Hey, look at us, we're here. This is our planet. This is our star. You can't miss us." Right? The rest of the world were particularly Europe, were well, no, that's crazy.
Immediately as you said that, I thought, that's never going to happen.
No, it's never going to happen. No one would be stupid enough to do that, apart from probably us. You're on the planet Earth. Yeah. But yeah, that's what the Americans were looking for, right? But they didn't have the computational power to analyze all of the sky, not on their own.
Yeah.
So they did an entire whole sky survey, right? Literally mapping all of the stars with this data, radio telescope data. And what they did is they put it online for you and I to download.
Right, okay.
It's called SETI at Home, where you could download this screensaver, and it would give you one little square of the sky that your computer could analyze the stars and what's out there, and then digitally send back the results, and they would just collate all the result, collect it, and extrapolate what had happened. Now, this is where Europe had a difference of opinion from America.
Okay.
Yeah. particularly one guy who was a Italian mathematician, not an astronomer, not an astrophysicist, nothing like that. He was just a mathematician. And this is how important mathematics is when you look at physics and astronomy and all that sort of thing, is that this guy was just a mathematician, and he took all their data and he looked at it and he went, right, I found 5 points of interest in all of this data that I think you could look at, and you might find something in your search for extraterrestrial intelligence. Okay. Now enters the room a company called Breakthrough Listen, who got massive funding. Yuri Milner is one of the people that funds it. There's rumours that Mark Zuckerberg from the Meta Group also funds it, but I don't know. I don't know how true that is. I don't know. All that is like from newspaper reports and stuff like that may or may not be true. I don't know.
I have heard he could be lizard. He could be a reptilian.
Could be. There's a good chance of that.
No, there's a serious theory that is out there that he's a reptilian.
But it doesn't matter who funded it anyway. But they have got literally $100 million of funding, right?
Only?
Just $100 million.
Yeah.
To look to help look for this SETI, look for extraterrestrial intelligence, but not just that. They wanted to look at like the most extreme things in the universe, like quasars and pulsars and the stuff that we don't necessarily quite understand.
I understand and know all of those things you just said.
Yeah, I know you do. Well versed in science,
Yeah,
you.
especially quasars. Oh, can't stop me from talking about quasars.
Except the kind of quasar you do involves guns and little laser pads where you score for shooting at different people.
I was thinking of Quavers, the crisp.
Oh, Quavers, not quasar.
Yeah. Or a little like platypus-looking animal. But anyway, I'm getting off topic.
Yeah, anyway, right. So, Breakthrough Listen, they had like a couple of different approaches, right? And one of the things that they wanted to do to try and help assist SETI in their search for extraterrestrial life was they came up with the idea that maybe, just maybe, if aliens are out there, we're looking for radio signals. Maybe they don't use radio signals. Maybe they're too advanced for that. Maybe they use something more like what we're starting to use in fibre optics, and they use like laser light.
Right.
Yeah?
I mean, lasers are very futuristic.
Yeah, and you can transmit data through laser.
Yeah.
CDs have been doing it for years, decades.
Very true.
Yeah? So they thought, well, why don't we look for, evidence of laser being used outside of our solar system? So they mapped, I think, something like 700 possible stars. It's sort of near, within 150 parsecs.
Okay.
Yeah.
Yeah, Han Solo could have done it quicker.
He probably could have.
Yeah, 150 parsecs.
And they found one star that had evidence of laser light being born from it. Right? Now, laser light.
750?
700 stars.
Wow. Okay.
Now, laser light is not a natural occurrence. Yeah, it's not even a word. It's an acronym. It stands for light affected by saturated emissions of radiation. I learnt that because I was learning to do tattoo removals, laser tattoo removals.
Yeah.
I had to go learn about all that sort of thing. So laser is not a natural occurring phenomenon. And they found one star in the night sky that had evidence of lasers coming from it. Guess which star it was?
Tabby's star.
Exactly right. You get an extra bonus point for that one. And they dismissed it.
What?
Literally. I mean, how many odd things about this star can there be for them to actually want to take a closer look at it? But no, they were like, oh, well, probably interference just here from Earth.
Why are they so against finding something?
I don't know, particularly with Tabby's star. I mean, how much strangeness do you want? How many flags can this star wave going, look at me, look at me, look at me, there's something here? and they're just, no, it must be interference.
So is there still division then? Are Europe saying, right, well, we don't need the Americans. Let's concentrate on Tabby Star?
No.
Oh, okay.
Because one of the, like I say, this Italian guy, he came up with 5 points of interest. One of them might have been Tabby Star. It probably was. But another one is now known as BLC 1, Breakthrough Listen Candidate 1, because it was one of his candidates that he said they should take a look at. And so they took a look at it. And this is where this alien signal comes in. Because back in 2019, they put a whole bunch of money at the Parkes Observatory in Australia. And because this area of the sky is in the southern hemisphere, so that's where they needed to be to look at it. And you can imagine, like, they're just pushing aside all these little scientists like Tabitha Boyajian. They don't, we got $100 million, we'll just fire some money at the observatory. Oh yes, you can have it. It's kind of like, how teenagers start a rock band and they scrape all their money together and they're like, right, I'm going to get a recording studio for the weekend, we're going to record our first single. Like Itchy Sack and the Nut Scratchers in the studio recording their stuff. Those are all these little scientists. Yeah, those are all these little scientists that really want that. And then Taylor Swift comes in and goes, nah, $1 million, I want that studio for the weekend. Justin Timberlake's come to record a duet with me. And that's what Breakthrough Listen kind of did to everybody else.
That's a good analogy.
Yeah, they were just like, yeah, we got the money, we're going to get our dish time where we want it, when we want it. And like I say, they took over the Parkes Observatory in Australia from April to May 2019. I know they at least 30 hours of watch time on a star called Proxima Centauri. Yeah, in the Alpha Centauri cluster.
That sounds very Latin or Roman.
It probably is, yeah. But it is our nearest stellar neighbour. It is actually the nearest star to our sun. Yeah, our sun is a star, unremarkable in every way compared to a lot of other stars. Proxima Centauri is a very, very small, it's only about 1/8 the mass of our sun, and it's what's known as a red dwarf. So it's quite dim, very small. It does have a planet going round it called Proxima b. We know this. We've done measurements. We've found a planet. If you were to stand on that planet, you'd be bathed in a very red light, quite a sort of dim red light compared to here on Earth. Yeah.
Okay. That sounds quite cool.
While they were looking at that planet, that's when they found that signal that I played to you at the start of the episode.
The radio signal.
Yeah. Right. That's where they found it. And they didn't actually publish a report on it until December 2020.
Hang on. How do I not know that signal is not just Itchy Sack and the Nut Scratchers, and that's their first song?
There's no lyrics.
Oh, fair point. All right.
Yeah. Their first song was called I Think I Got Crabs. So, you know.
Oh, yeah. No, that's classic. Yeah. I think I got crabs.
Yeah.
It's been on my mind since you said it, and I'm like, that's such a good name for a band. Like Itchy Sack and the Nut Scratchers. How has no one thought of that before?
I don't know. Probably wouldn't get released if anyone did think of it.
If their hit single, I've Got Crabs. Wow. Okay, so I'm getting so distracted.
Yeah, okay. Where was I?
The radio signal.
Right, yeah. So, yeah, looking at Proxima Centauri, they found a radio signal. Now, this is where I want to dispel some things that possibly some YouTubers, even the guy who actually broke this story, may not have got quite right. Now, yes, they were looking at Proxima Centauri, but they say that their best guess, really, is that this signal came from somewhere in a circle of sky of 16 arc minutes of Proxima Centauri. Now,
What, is that the window, 16 minutes that they were looking?
No. You don't know what an arc minute is, do you?
No.
Right, okay. Well, we've got to talk about 16 of them, so I'll break it down. Now, you know when you're looking for coordinates here on Earth,
Yes.
and you go N 64, 20, 36
Yes.
west, blah, 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 right? Those are divided up degrees, minutes, and seconds.
Yes.
Yeah?
Yes.
Same in the night sky. You can divide the night sky into degrees, 360 of them. Mm-hmm. Yeah? Each degree is around about, I know it gets thinner towards the poles, obviously, but as a ballpark figure for you, right, 1 degree, one strip of night sky of 1 degree is about 2 widths of the full moon.
2 widths of the... Okay, yeah, right.
Yeah, 2 full moons wide.
Okay.
That is 1 degree of sky.
Right, okay.
Yeah, so you'd have to divide that into 60, because 1 degree is basically 1 arc hour. Mm-hmm. Yeah, so divide that into 60 to get an arc minute.
Right,
Yeah.
okay.
And we're talking about an area of sky, 16 of these. So if a degree is 2 moons wide, 16 degrees is around about half a moon wide.
Yeah.
Yeah?
Okay.
So a circle of sky that's half a moon wide and half a moon tall. Yeah? And we're looking at a pinprick of light that isn't even visible to the naked eye.
Oof.
So there's quite an area around Proxima Centauri that this signal could have come from.
Yeah, yeah.
And to add to this is the problem, the main problem of this is that Proxima Centauri and Alpha Centauri are named after the constellation they come from, Centaurus. Yeah? Centaurus is pretty much astronomically right next door to Sagittarius. Sagittarius is pretty much the heart of the Milky Way Galaxy. Yeah?
We're both Sagittarius.
We are both Sagittarius. That's our star sign, yeah. But the constellation of Sagittarius is what contains the supermassive black hole at the center of our galaxy. It's where everything is rotating around. It's basically the most densely populated area of sky that you could possibly be looking in.
That's pretty cool.
So they're looking at Proxima Centauri. They've got a signal that's come from somewhere within 16 arc minute circle of Proxima Centauri, but there must be tens of thousands, hundreds of thousands, even millions. So remember, there's 200 billion stars in our galaxy.
Yeah.
So in that little circle of sky, there's quite possibly hundreds of thousands of stars with millions of planets going round them that this signal could have come from.
So it is quite literally a needle in a haystack.
Yeah.
Yeah. Okay.
And that is the main point that I kind of wanted to clear up for everyone, because everybody's going, oh, we found this alien signal and it's right next door to us. No, it's not. Not necessarily. It could be, but, and here's the clincher, right? Proxima B is the planet that we know is going around Proxima Centauri, our closest neighbouring star. Now, the one of the key things about this signal that we've detected, okay, we've detected a signal above background noise. We know that. It's a narrow band signal. It's a 982 megahertz or thereabouts, right? So it does stick out, and it's kind of like a needle point above the background noise.
So it's a prominent sound.
Yeah.
Yeah.
And it has something that's called Doppler shift. Yeah. Now, you know what Doppler shift is. Everybody knows what Doppler shift is. You hear it every time an ambulance goes by. When it goes, Nina, 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 Nina. Yeah?
Yeah.
So this signal is getting stronger and weaker and stronger and weaker. And the thing that makes us almost 100% certain that it's come from somewhere else is the fact that it doesn't line up with our own planet's spin. If we were rotating, the planet was rotating away from that point in the sky when the signal was getting stronger. Which means that signal must be coming from a planet that is rotating and was rotating towards us. You know, that the point on the planet where that signal was being transmitted from was was on a point of the planet that was rotating towards us at the same time as we were rotating away, which is why it's getting stronger where it should have been getting weaker.
Okay.
This is one of the things that makes us, pretty certain that it's a signal that has come from off our world.
That's very interesting. Very sci-fi.
Very good, isn't it? Now, the problem is, like I say, when they released this information in December 2020, they looked for it again, couldn't find it. Now, scientists like things to be backed up. They like to cross the T's, dot the I's, make sure that they can find something again, measure it again, before they're going to say with any degree of certainty that, yes, this is something that we have found. And they couldn't find it. So they sort of brushed it aside and they said, well, yeah, it could have been an alien signal, but it's equally as likely to have been Dave heating up his microwave meal in the canteen that caused some disturbance on our instruments. It might be something that we've done.
Is that possible then? Something as small as that?
It might be a hairdryer in the next village over. We don't know. This is the thing. Because we only saw it the once, we don't know. And that's what a lot of scientists are saying. A lot of SETI is saying, particularly like the American, like NASA and that, they're going, well, we only found it once. We can't prove it. We can't recreate it. None of that. So let's just brush it to one side and in the same closet that we put Tabby Star, and just put it to bed, right? But Europeans, we're a plucky lot, aren't we? Right?
Oh yes.
We weren't to be put off, and there is a Dutch company from the Netherlands called Astrum, and they're very clever. This is another science institution that has decided to take it upon itself to collect data from radio telescopes all over the world. Any radio telescope that's been pointing its dish in the direction of Alpha Centauri and Proxima Centauri over the last few years, they're saying, give us your data, right? Now, there is a problem with this, and it's like, it's kind of like all of these dishes are going to be out of phase with each other because all of this technology, whatever you've got, basically, everything from any kind of radio telescope or most technology, your computer at home and whatnot, they all have internal clocks. Yeah? And the clocks don't always line up. So to just bung all the information into the mixing bowl and hope that you get a signal out of it doesn't work because they're all out of phase with each other. It's kind of like we record our audio and our video separately, and every week when I go to edit it, I'm constantly having to cut and move the audio back in line so we can lip sync.
Yeah, makes sense.
Yeah. Or another analogy is if you were to switch on your old school car radio over to Dribble FM or something.
My favourite.
Yeah, and you're listening to it, and the DJ comes on, and that was the latest song by Itchy Sack and the Nut Scratchers. Check it out for more. Right. Now, you switch on, right next to it, you switch on your DAB radio, you get like an echo, yeah?
Yeah.
The DJ's only said it once, but it's coming through at different times. They're out of sync with each other.
Yeah, they're not perfectly in line.
Exactly, yeah. And the same as if you were to pull it up on your computer and just use the web player, you'd get another different time. So it would all sound a little bit echoey and muffled.
I gotcha.
Right. So, the Dutch have found a way of synchronizing all of these dishes.
God, those smarty pants.
Yeah, they use a really big word called multiplexing to say that they're going to literally synchronize all of these and get all of the data and try and read something from it to see if they can re-find this signal to prove that it was there. And that is the confirmation that we're waiting on.
That's the main thing.
That's what we're waiting on. And they have said categorically they are interested in BLC-1. They want to see if they can find this alien tech signature.
Yeah,
but
yeah.
as we know, scientists like to cross the T's and dot the I's, or the other way round, which, as long as they get a result that they can present and be 100% sure about, because they love nothing better than to test each other's work. They call it peer review, where someone goes, "Oh, I've got this theory, I've found something." Right, so they hand it all out to their science mates, and all their science mates start doing the equations and working it out, and until all of them go, "Yes, I agree. Yes, I agree. Yes, I agree." They're not gonna say anything. They're not gonna tell us. But unfortunately, because this story has hit, it has even hit the main news here in the UK. I think it was the Mirror that published the story saying, "Oh, in 2 weeks the scientists are going to say that whether we've encountered aliens and all this sort of stuff." Now, this has got kind of out of hand. This is why I wanted to come and tell the story. And even though it's not going to go out for a few more weeks, when it might have even all blown over by then, at the moment, like, the government are starting to put packages together, a presentation together, so that they can present this to the country. Many countries are. King Charles III is being urged to make a speech to, because
King Sausage Fingers.
King Sausage Fingers, yeah. He's literally being urged to, because he's a very calming influence, the way he speaks and stuff like. Well, that's what they assume anyway. He's going to be he's going to be able to put together a very good presentation to make sure that everybody keeps calm and carry on. Even the Pope has been told that he may need to make a presentation to the entire Catholic Church to tell them that we're not alone in the universe.
Well, that's going to be a lot of shocked little boys, isn't it?
Yes.
Catholic Church. Sorry.
But this is why
PG.
I wanted to make this... Might have to edit that. This is why I wanted to make this presentation, to bring the facts and dispel some of this, this clickbait that's been going on. Because we don't know exactly what it is. We can't say 100% sure that, yes, it is aliens. It's not an imminent announcement that's coming out. We don't even know when the Dutch are actually going to release this statement. They've been working on it for, since 2019? Well, probably they haven't been working on it since 2019. But they've had data there from 2019 to analyse. It might take them another 5 years. Who knows?
So why has this only come out now?
Because of a certain YouTube channel called Professor Simon Holland, who is not necessarily a astronomer. He's not like he hasn't got a PhD in astronomy or physics or anything like that. What he is a science filmmaker. His job is researching and fact-checking for science documentaries like Panorama, BBC News, stuff like that. So it's his job to go around finding out these things. And he's a filmmaker himself. He knows how to put together a good video. And he knows how to make a good thumbnail on YouTube. And he knows how to create a good title. And he has literally clickbaited thousands of people into believing this story. And I'm sorry, Simon. He does put a good presentation and it's a good theory that he's put forwards, but he has kind of sensationalized it a little bit. Even one of his video titles, I think, on his thumbnail, it says it's not a matter of if, it's when we find out that aliens are out there. That's not necessarily true. I mean, it kind of is, but it's not necessarily. Not necessarily from this time round.
But that doesn't necessarily mean that aliens are here, they are on the planet. It just means that out there, somewhere
in the
solar
science community
system,
that we can observe in the night sky, we may have found some evidence for them, but there's no confirmation yet. I will keep on top of this story, and I would say that I'll bring it to the table when it does get released, but I won't need to, because it will be global news. It will be the biggest story ever told. It will be on every newspaper, on every TV channel. You won't be listening to a Paranormality to find this out. It's going to hit the front page before we even get a chance.
Yeah. Why do people always assume that aliens are really, really advanced? So when you're saying there could be proof of life out there in the solar system, Could that just be microorganisms or plants, or would it have to be super knowledgeable aliens?
If you were to say, we know of 1,000 planets out in the night sky that definitely have aliens on them, probably only one of them would be intelligent life. The rest of them would be microbial or insects or, animals, plants, stuff like that. There's a theory called the Great Filter that is also out there that states that maybe a technologically advanced species, before it actually gets to becoming spacefaring, being able to go out into space, wipes itself out before it gets there.
Yeah. I've heard that theory before.
Yeah, like we're always on the verge of blowing ourselves up. And
are we?
The furthest we've gone is the moon, which I believe. Some people don't even believe we've got that far.
Yeah.
So, yeah, I mean, the chances are there's millions and millions, possibly billions of forms of life out there. But out of those billions, there's only going to be a handful that are technologically advanced. We may have found one. We may not have. We don't know.
I think people forget, myself included, how big the universe is.
Oh, yeah.
Do you know what I mean? Like, I think when...
Yeah, and we're only talking about our galaxy.
Yeah. And isn't it... I saw like a video where it was trying to explain the size of the universe and how we can't... our brains cannot comprehend it.
No, we can't.
And it was something like if you looked at the Sahara Desert and every grain of sand was a galaxy or something along those lines, or 100 million galaxies in that one grain of sand, that is... the size of the universe. Like, you just can't wrap your head around it.
There's more stars in the sky than there are grains of sand on the entire planet.
Yeah, that's nuts, isn't it? Absolutely nuts. So, well, I look forward to finding out.
So do I, mate. I really, really do hope that Simon Holland's right. I do hope, because I'd love to be of the generation of people alive on this planet that finds evidence of alien life out there, and forgetting about all the UFOs and stuff and abductions and all that sort of thing, but the actual science fact, tangible proof. I'd love to be part of that generation. I mean, I'd love for them to land on the White House lawn and make themselves known, but I don't think that's going to happen in our
Not the White House. Come to Europe.
Come to Europe. Yeah, that's a much better idea.
You can have some Danish pastries. You can say hello to the Dutch. You can do some lovely things.
But anyway, this presentation has taken longer than I thought it would. So, what do you give it?
Well, it's a tough one, man. I know I say it with every subject we do. It is a tough one. Because this essentially, for me in my brain, is saying that, like, forget all the UFOs, forget everything like that. That's all rubbish. This is actual evidence. So it kind of discredits all of the stuff that we know about aliens.
All the normal stuff that we talk about,
But I'm very impressed with the Dutch bringing together all of the synchronizing everything.
Yeah.
That's really cool.
Something that the Americans didn't think of.
Well, yeah, the same people that tried to invent a pen to go into space, but
and the Russians use a pencil.
Yeah, stupid. So I like it. I think it's really cool, and I learnt a lot today. So I'm going to give you an extra point for that, because I learnt quite a bit today, which is nice. You know what? I'm going to give it a 7.9.
Yeah?
Yeah. I'm going to give it 7.9 because there is that little bit of uncertainty. I feel like I can't go into the 8s yet.
Yeah,
do you know what I mean?
Fair. Yeah.
If there was a bit more confirmation, or the Dutch were like, we've got an answer, we're going to have it within a year or something, and it ramped it up a little bit, I'd be like, oh yeah, this is getting juicy. This is like an 8.5. But because there's still that, like you said, it could take another 5 years.
Yeah.
I'm going to give it a 7.9, so it's just on the verge of like, I'm waiting for it to get juicy again. Do you know what I'm saying?
Yeah, fair enough. All right, yeah. Well, I was similar to you. I was thinking about 7.5 for basically the same reason. I'd love it to be true. I really, really, really do want it to be true, and I will tomorrow, and I will until I actually get an explanation for it.
Yeah.
But there is that level of uncertainty. We don't know. It might be Dave reheating his roast dinner in the microwave, you know?
Forgot about that.
You never know. But, yeah, I'm going to join you at a 7.9. Because like you said, I'd love to tip it above the 8. But
Yeah.
I think it's too early to do that.
So our average is a 7.9.
7.9.
Yeah, that's fair. No, a very good presentation, mate. I liked it. I think that's getting the science heads out there
And
thinking.
not a single T-shirt sales pitch.
No. No, there's not even enough time. Quick.
No, quick. Right, I've been Pirate.
I'm Josh.
And this has been Paranormality UK. Ta-ta.
Ta-ta.